Good afternoon. I'm Bob Rubin, and welcome to our Hamilton Project discussion, Advancing U.S. Innovation by Reforming Patents and R&D Policy. We will turn very shortly to the beginning of our program, which is a fireside chat. But before that, let me make a few comments to set the stage for this discussion. I think there's broad-based agreement across party lines, across policy lines, that strong economic growth and widespread economic well-being, the two interdependent objectives, presumably, of economic policy, depend very heavily on productivity growth. And productivity growth, in turn, as all of us know and is well known in the policy community, depends heavily on robust innovation, which means new products, new processes, and new technologies. The United States has a dynamic and entrepreneurial culture, and that is certainly a fundamental requisite for innovation. But innovation also requires policies that stimulate and incentivize innovation, policies that are conducive to innovation, and policies that provide the necessary underpinnings. That includes a whole host of areas that we are not going to be discussing today, but let me just briefly mention them, such as flexible labor and capital markets, a regulatory regime that is based on cost-benefit analysis, but also meets our regulatory needs, a greatly improved, multifaceted human capital agenda, appropriate tax incentives where externalities are involved, and much else. And we at the Hamilton Project have, over the 12 years of our existence, convened discussions on all of these subjects multiple times. But the program today is going to be focused on much more specific areas. One will be the many issues, legislative and administrative, around patents, and then various other issues that will come up, including this very interesting subject of what can be learned from pharmaceutical industry with respect to innovation in other areas, particularly applied to innovation in energy. We all know that our political system has, very unfortunately, been largely dysfunctional for a long period of time. And the consequence is that while we have tremendous long-term strengths and we should be successful as an economy over the long term, it is requisite, that is to say, the realization of that potential is requisite on meeting hugely consequential policy challenges, and predominantly those have not been met for a long time. But innovation is one area where there is widespread bipartisan agreement. And therefore, it does, it seems to me at least, it seems to us, create the potential for administrative and legislative action. Therefore, it seems to all of us, in the various capacities that we occupy, should urge our elected officials to focus on innovation and its requisites, because as I said a moment ago, that is one of those unusual areas where at the federal level we should be able to move forward. Moreover, in some of these areas, the states can be very useful. And so there, too, we should be involved, in the Hamilton Project we are involved, in talking with state governments about what they can do to spur innovation. Let me mention one more item, if I may. There's a document in your materials, the facts relating to patents and innovation. And it is really worthwhile reading. There's a lot of interesting material in there, but let me just point out one particularly. And I think it's fact 7, if I remember correctly. And it makes the point that immigrants, have been disproportionately, very disproportionately constructive in this country and active in patent applications. And it's just one more example of how immigration has contributed in a very positive way to our economy. The program participants, the discussants, and the paper's authors are described in your materials, and I will not recite from their resumes, but as you can see, they are a truly outstanding group. We are very grateful to them for joining us today and for helping all of us think through these very important issues. Let me close on one totally different point, but it's been on my mind lately. The discussions we're going to have today seem to me exemplify a point about independent policy organizations like Brookings, where we are here today, the Hamilton Project, We're housed at Brookings, as you know, but we're self-governed and self-funding, and others, AEI and others, that are serious-minded and really are committed to serious to purpose about policy and policy development, policy deliberation. It is true that probably at this point in time, relatively little is going to be accomplished at the federal level in most areas, but it still seems to me that kind of work can have some effect. It can certainly also have effect in the states, and it is very important in creating the intellectual work product for when we for those politicians who are committed to governance and for when we once again, hopefully, reestablish effective governance. And the way to test that proposition is just think of the counterfactual. What if we had the political environment that we've had really for quite an extended period of time, and we didn't have these independent policy organizations to keep alive serious to purpose? With that, let me recognize the terrific Hamilton Project team, Jay Shambo, former member of the CA, now our director and intellectual leader, Kristen McIntosh, our exceedingly effective managing director, Ryan Nunn, our deeply knowledgeable and thoughtful policy director, and our talented staff, without whom none of what we do could be done. And with that, I will turn the program over to Greg Ip, the highly respected chief economics commentator of the Wall Street Journal, and Kevin Hassett, chairman of the President's Council of Economic Advisors. And Kevin, we are really delighted that you were joining us for today's discussion. So Greg, well, Greg disappeared. Oh no, he says he's here. Okay, Kevin was hiding him from me. Okay.
Go on a diet.
No. Thanks. Greg just has to assert himself more. Okay.
You're going to be sorry you said that.
No, I'm going to be sorry you said that.
Okay. Thanks very much for joining us, Kevin.
Oh, thanks.
So to paraphrase Bob Solo, you see innovation everywhere today on the smartphones and the headlines. You see it everywhere except in productivity statistics. It's been a rough decade for productivity growth. And what's going on here? Does this country have an innovation problem, and why does that matter?
Sure, and thanks. And before I answer that, I just want to thank the Hamilton Project and Brookings for having me here, and especially Secretary Rubin for your thought leadership. I think that right back in the beginning of 2006, I remember maybe the second or third Hamilton Project event was about patents, and that your vision of creating an organization within an organization that is filled with just real policy proposals created by the smartest people that you can find has been just it's been proven in practice by the output of the Hamilton Project. It's just been fantastic, and I can tell you that there's probably not been a Hamilton Project paper I haven't read and haven't referred back to since being in the White House, so thank you for your leadership on that.
Careful, Bob's going to call an end to the event right now.
Yeah, that's right. But you do need to do a study on corporate taxes and wages, though, I think. I will go look it up. But anyway, back to productivity.
Sure, yeah.
I think that, in fact, it's another thing that Brookings has really been a leader in, that there have been so many conferences in the past few years that have informed my thinking on productivity growth. And I think that really quickly, my summary of what I've learned from papers that have been produced within these halls or solicited by these halls is that there's the sort of Eric Brynjolfsson argument that because neural nets and machine learning and everything are advancing so rapidly that we ought to innovate faster. And then there's the Bob Gordon point that, well, nothing will ever be as good as air conditioning in terms of how much it'll help productivity. And I think that what I've learned from all the Brookings papers I've read on this is that their debate is a little bit of a non sequitur, that if you look at productivity inequality, it's going up a lot, and that the innovativeness of the most productive firms is sort of consistent with Brynjolfsson's view of what ought to be going on. But that the difference these days is that the innovation, the productivity gains from innovation are not diffusing down at the rate that they used to. And that the challenge for policymakers, and I guess at CEA I provide objective advice to policymakers at the very least. I don't think of myself as a policymaker, but policymakers need to think about why has the diffusion slowed, what can we do to address it. And I think that the link that I find most compelling is that in order to get from innovation to growth and to productivity, then you need entrepreneurs. And that if we look at the data, the thing that's really most striking about recent years is that entrepreneurship has really fallen off. The Economic Innovation Group did a study of it that suggested that millennials are the least entrepreneurial generation that we've seen in U.S. history. And so I think that as we think about how to get better the innovation is happening. It's just not diffusing, and maybe that we could think of as an opportunity.
So a huge part of the policy effort of this administration and this Congress right now is in tax reform, which of course is a specialty of yours. To what extent can tax reform, especially the one that seems to be taking shape right now, actually help the innovative process, if at all? Is there a link between the tax system and innovation?
You know, and I think that the news was breaking just as I was walking in that they've announced that they've sort of agreed to something in conference that looks likely to become law. And I think that there is a link between tax reform and innovation. And I think to think about how that link works, we could go back to back when I was in grad school. Then one of my professors was Dave Cass. And Cass and Koopmans had been leaders in the 60s in the development of the neoclassical growth model. Which showed that if you have more capital investment, more labor, then you get growth in the short run. But in the long run, basically growth was exogenous. And then just as I kind of left graduate school,
which is another way of saying that you really can't do much
about it. You can't do anything about growth. This stuff
is
just given to us from the heavens.
Yeah.
And then, but then there were a bunch of empirical patterns, and it's kind of one of the advantages that you and I both have recognized for aging, right, is that we actually remember how literatures got started because of puzzles, and I think sometimes people forget the puzzle. Well, the puzzle that started the endogenous growth literature was that especially capital spending relative to GDP or investment relative to GDP seemed to affect long-run growth more than was consistent with the neoclassical growth model. And so therefore there's a interaction between higher capital spending, which we think will come from this bill, and things like total factor productivity growth. And that literature has certainly evolved a lot, but the basic puzzle started from the fact that productivity growth, even total factor productivity growth, seemed to interrelate with investment. We could go into that literature more if you want. There's sort of three strands of it, but there's one that tries to model innovation by looking at investment in R&D, and I think that that's the one that's the most promising.
But to sort of cut to the chase, so the brute force mechanism of this tax reform on growth is that you lower the cost of capital, there's more capital spending, higher capital stock. How does that translate into innovation? I mean, maybe we just get, more bigger locomotives, right, deeper minds, but not necessarily more innovation. Right.
Well, I think that it can lead to more innovation if it increases the rate of return on innovation. And so there'll be more investment in that, and I think that that's probably the biggest thing. But it can also lead to more innovation if it helps us with that problem, which I think if you look at the individual side, it has some promise to, of the sort of disappearance of the entrepreneur. Because we've got to have people take the innovation and turn it into something that's a business. I think one of the problems with entrepreneurship too might be that if you're a young, smart person, if you invest in professional skills, then you get, in this day and age, a pretty high income that's not that risky. And so that bundle is a lot more attractive to a lot of the most talented people these days than becoming an entrepreneur, where you get a risky income, and maybe it's a lot higher. And so I think that things like marginal tax rates might help with that.
Okay. Just a reminder to the audience, in about 5-10 minutes, we'll take some questions. And there are staff members with cards that they will give to you. You can write them down, and the cards can be passed up to me. And if you're watching this on live stream, you can tweet a question to @HamiltonProj. It's definitely the case that a higher return should create more investment in innovative activity. But it's been well established that the returns to society go well beyond just what any individual company is going to get. And so we've long recognized that there should be public incentives like direct federal financing of R&D. Now, this was before your arrival, but the first Trump budget proposed cutting several important types of federal R&D. For example, NIH would be cut, say, 22%. The Office of Science in the Department of Energy would be cut something like 17%. In the event, a lot of those cuts did not go through in the appropriations process. But how do you reconcile?
I think almost all of them didn't go through.
Oh, is that right? Okay.
Yeah, that's right.
How do you reconcile this proposed reduction in direct federal contribution to R&D and the widespread recognition that R&D is important and that research is important?
Right. Well, I think that, first of all, if you look at the attitudes towards research of the sort of people who control different areas in the government sector, that they've done a pretty good job, I think, of moving government R&D back in the food chain, so going back to really basic research. And I think that there's this view that maybe we could spend too much time researching things that maybe private firms could better do because it's like near the end of the chain of discovery, and that there's a refocusing right now on high value-added research. And as an economist, I could say that my read of the literature is that the social return to basic research is enormously high. And that suggests that the government should engage in it, and also that the government should subsidize it at the corporate level too, because the social return from even for their research won't all be captured by the private firm. I think that the latest research suggests that the social return to research at the corporate level is about double the private return, which suggests that there's ample room to make sure that we're a good place to do research.
Is there a sense that the federal government's support for R&D has not been efficient, that it gets you could get more bang for its buck?
Well, that's certainly, I think, the sense that I have when the president's budget was put together. I think guys like Reed and Chris in the Office of Innovation were really looking at what we were doing and trying to think about how we could spend it better. And I think that the fact that there's an Office of Innovation in the White House, I think, emphasizes how important we think that is.
Okay. When you go into the, as Bob was saying earlier in his introductory remarks, I mean, one of the facts the Hamilton Project lays out for us is the striking contribution of immigrants to the R&D, to the innovative process, whether it's as entrepreneurs, whether as people who develop the knowledge that leads to patents and so on. And there is a perception out there that there is a tension between that recognized role of energetic immigrants in contributing to our entrepreneurial process and this administration's efforts to reduce immigration, both legal and illegal. Can you talk about how the administration addresses that tension?
Sure, and I don't view it as being a serious tension. You know, I think that the literature is clear that immigrants tend to be very entrepreneurial. There's a very logical reason to expect why that would be, because imagine if all of a sudden everybody in this room, we had, pick some random country where you don't speak the language and we had to go live there. Then we'd be very frightened of that, right? And so the people who have the courage to move to another land and then try to make a life for themselves tend to be talented and risk-loving, and they're exactly the kind of people that you would want to have come to your country. And it's very much in the evidence they're about twice as likely to be entrepreneurs, immigrants, as native-born Americans. At the same time, there's a lot of parts of our immigration policy that haven't been working very well, and our borders haven't been very secure. And I'm not an expert on border security, but I'm glad that there are people that are doing that. Before I entered the White House, I wrote an article a few years back that'd be very easy to find. The Senate's confirmation people were very good at finding this article before my hearing, where I basically just speculated that because we've done such a bad job of enforcing the law, the rule of law in our country, that there's sort of a paradox about America that immigration is very, very contentious politically here. It's an extremely hot-button issue, much more so than you see in many other countries. And yet even immigration of illegals plus legals relative to the workforce is one of the lowest in the OECD. So that I think Japan and France are the two that are about where we are, and everybody else is way above. Now, of course, with Europe, it's a little, because of the mobility, it's a little hard to look at that statistic. But I think that immigration policy in the U.S. has been so terrible and so contentious in part because we haven't started by getting the sort of enforcement part right. And I'm very hopeful, and I'm looking at what's going on in the White House, that they'll get that right, and then they can move on to things like working towards getting a more rational immigration policy and getting the right kind of workers into our country.
But wouldn't it be the case that reducing the level of illegal immigration, as for example, Senator Cotton and Senator Perdue have proposed in the Senate, largely by reducing the family reunification portion of that, just as in a mechanical sense, would reduce the inflow of immigrants in the future? Would that have some impact on our growth and especially our innovative effort?
I think that if we get immigration right, then and make sure that it's serving the purposes of the vision of our country, of our founders, and the citizens of our country today, then it'll be very easy to expand it once we get it right.
Let me talk about actually, let's talk about one of the subjects that you will hear about later today, and that's patents. And in fact, you've studied patents a lot in your life prior. You studied a lot of stuff in your life prior to coming to the Council of Economic Advisors, but this was a special area of interest to yours. There seems to be a consensus that the patent system in this country does not work very well. Do you agree? And what can the federal government do to make it work better if we want more innovation?
Right, so the patent issue is crucial because the empirical link between patents and economic growth and patents and productivity growth is pretty strong. And I think that going all the way back to maybe 2006 Hamilton project, that there's been this sort of problem that sometimes it's almost like every patent gets accepted, and then there's all these patents out there, and then everybody's suing everybody else, and it makes it very hard. And one of the things that I think I've been convinced by the work of this group about is that it's hard, especially for the little guy with a good idea, because that person person won't necessarily have the resources and the lawyers to defend their property right against the other guys who sent in patent applications pretty close once they saw the guy's idea. And so I think that there's a lot of room for patent reform, and I'm I guess happy that it's on the agenda here today. One
more time, if you have a question, just put up your hand, and we will come to you and get a card. And we'll just a couple more questions, and we'll get to those. I know your time is valuable, so I don't want to delay the Q&A too much. But
actually, your taxes are paying my salary.
Is that right? Okay. All right, you can stay here all afternoon.
Yeah, indeed.
Let's talk a little bit of regulation. This administration has made a very big push to try and reduce regulation from the premise that that's been a burden on growth. Do you think there are specific areas where regulation has impaired innovation and growth in this country? And what are those areas, and how do we fix that without sacrificing, safety and consumer welfare, all the stuff that we also want?
Yeah, safety and consumer welfare, regulation is extremely important. And then I think that, what we've sort of done this year is take a time out, and there have been very, very few economically significant new regulations this year. And one of the things that I've found from our study of this is that it's sort of surprising how much new regulations, what a tax they are on the economy, because if all of a sudden you and I are running a business and there's this new regulation, then we have to hire a zillion lawyers to figure out how's that going to affect what we're doing. And I think that the positive effect of the pause is sort of bigger than I expected. But I think that
sorry, in what sense is it bigger than you expected?
Well, I think it's one reason why sentiment and growth are looking good. It has to be, because there's a lot of ambitious analysis going on at OMB and elsewhere to deregulate. They're going to have a progress report coming out. There's always one every December coming out really, really soon, where they're going to list their accomplishments, and there are many. But they did start in the beginning of the year, and those things would be just washing through right now. And so I think that it must be the case that at least animal spirits created by a pause in regulation have been a significant factor driving growth up above 3% like it is right now. But I think that the way to think about it economically is just that regulation is a fixed cost, that figuring out what am I going to do about this, what am I going to do about that, and that fixed cost is an obstacle to entrepreneurship. And I could even like outside of the business sector a while ago, some friends of mine and I saw a need for a nonprofit to support youth sports in parts of town where there weren't a lot of dads that were organizing the little leagues and stuff like that. And we started a foundation called the Urban Baseball Foundation to do that. And it just was a nightmare to get through all the regulators and all the tax people to get it. I just can't tell you how long it took. And none of us were taking a salary, and we were putting our own money in it and stuff like that. And it was really hard to do.
But were any of them federal regulators?
Yeah, because the tax-free status and stuff was
is that right?
That stuff is pretty hard to get as well. But anyway, so I think that red tape and all that, it's a serious deal. And it's not just me. If you look at the OECD pillars for economic growth, then one of the key ones that they mention is that deregulation can lead to economic growth. And if you look at the OECD rankings of how high the costs are of regulation, the U.S. is really right near the bottom. And so we could get very significant growth effects from deregulation if we could just approach the level of regulation that they have in, say, the Netherlands.
Interesting.
Yeah.
Can I get the questions now? While I'm waiting for those, one last thing. So a subject near and dear to the hearts of many people in this room is higher education, and they're looking with a certain degree of anxiety at the tax reform, which will take away some of the tax breaks for higher education, for example, deductibility on some forms of debt, taxes on endowments of certain institutions. Does that, given that we're looking to the higher education system often to generate the STEM graduates and the knowledge base that propels growth, is that part of the tax reform potentially negative for growth and innovation going forward?
I don't think it is, and I think that again, it's part of the STEM problem is not necessarily that the opportunity isn't there for people to get STEM education. It's the people choose not to do it, and I think that rewarding higher salaries with higher after-tax income will certainly have a big impact on people's decisions to do things like engineering. It's interesting, again, if you look at the latest literature, it's clear that we do need a lot more STEM people. The engineering share of the workforce in manufacturing companies is really highly correlated with their place in the productivity distribution.
We have way more questions than we have time, which is too bad, because these are actually very good questions. Very important one. What are the policies and ways, especially for the federal government, to address the needs of workers and communities that are themselves, in some sense, on the losing end of innovation as we replace their skills and their industries with improving and better and new technology?
Well, I think that one of the things that was in the Senate bill, and I'm not seeing the final, I know there's just an outline that's been agreed to now, is a kind of enterprise zone on steroids. That is something that Jared Bernstein and I a while ago wrote about. But I think that, first of all, by having a lower corporate rate, firms are going to want to locate plants back here. And with the unemployment rate so low, they're going to want to locate those plants in places that have a lot of available workers. And I think that we've put that thought on steroids a little bit in the Senate bill, at least, with a really expanded enterprise zone that will encourage people to locate their activity in more distressed communities.
On tax reform, after the bill is signed by the president, do you think large high-tech companies like Apple and Google will bring their large overseas profits back to the United States? And if so, where does that cash flow end up going? Will it stimulate investment in R&D, or will it simply go to like paying for dividends and share repurchases?
Yeah, and first of all, you know, as Secretary Rubin will tell you, that if a large mature business returns capital to society, then that is capital that can go to young entrepreneurial folks. And so I don't think that we should pillory firms if they increase their dividends as a part of this tax plan. But I think that we should contrast what's going on in the bill now with what happened the last time we had a dividend repatriation holiday. Back then, we gave a kind of lump sum tax refund to people who had a lot of cash out offshore. They brought it home, and the Congressional Research Service tells us that maybe it was the GAO, it was one of the two.
They'll do great work.
Yeah, that's right. But they showed us that it basically went right into dividends, and that there was no capital spending effect whatsoever of the repatriation holiday. And I think that that's fully consistent with the models that we at CEA used to model this tax reform, because we didn't change the marginal corporate tax rate. We didn't do anything to make people want to invest in plant and equipment here in the U.S. We just gave them a lump sum tax holiday, and they did what we would expect. But I think that the difference is that people will want to locate activity here more now because the rate is so low. And there's still going to be an issue with transfer pricing with the really, really big firms. But I think that at the margin, we should expect a lot more capital spending in the U.S. because of the bill. And the repatriation part of it can help finance it, which is important, because I think you know, that there are there's a range of model estimates of what can happen to the economy because of this tax bill. And the models that find smaller effects tend to do so because there's a lot of crowding out, because the firms want to invest more, but they don't have the money, and because people don't save more, and then the interest rate just goes up, and you don't get much more investment. But there's all this cash offshore. There's all this transfer pricing of profits overseas, and you know, in the speech I gave at the Tax Policy Center a while ago, I showed that the increase in investment we expect to see is something that can happen almost entirely within the current account, because there's all this money that's being transfer priced to foreign subsidiaries, that if they stop that they can use that money to finance investment, and it doesn't require a higher saving rate.
So when we see announcements of companies saying, well, we're going to start increasing share repurchases in part because of the tax reform, is that a sign that it's working, or that's not working as advertised?
I think that repurchases and dividends could go up in part because they can now get the money home and return it to domestic investors, and then those investors will recycle the money and put it into perhaps more entrepreneurial firms. And so it's kind of removing a lock-in effect, so it should be a good sign, I guess. But the sign that we really need to see in order to know that it's working as intended is that capital spending goes up as a share of GDP next year.
Okay, so in other words, you shouldn't focus too much on looking at how one specific company rearranges its financing. Okay,
that's what I think. But I do think that it would be completely fair if you know, next December we're on this stage and you say, geez, capital spending, you know, was down a little bit this year. Isn't that the opposite of what you said? Then I'd have to say, yeah, that's not what we expected at all.
They're totally loving this, Kevin. They're giving us 5 more minutes. How can we make patenting, and I'm going to add here innovation and STEM, more accessible to women and racial or ethnic minorities? we need everyone around the table to innovate. Women are listed as innovators on fewer than 20% of patents.
Yeah, and you know, I think that access to the capital to you know, go to college and so on is something that can help with that, but also fixing schools with the minority part of it, that like the STEM education in many schools in America is really unacceptable. And I think that you know, Secretary DeVos has got a lot of ideas about that.
Given the importance of structures to gross fixed investment, is capital deepening possible without land use reform? Is zoning, for example, zoning, is there any way for the federal government to help? And I'm going to actually add to that question, what's the justification for allowing accelerated expensing of equipment but not structures?
So there's a technical answer to that, which I
You're
really,
and
then after that, remind me. No, but it's just that the way that depreciation enters in the user cost of capital is in the present value of depreciation deductions. And for something like a building that's depreciated over, you know, more than 30 years, then the present value is way less than 1. And that present value depreciation deductions hits the statutory corporate tax rate in the user cost formula. And by cutting the corporate rate from 35 to 20, then it turns out that the user cost effect on structures is, you know, is bigger than it is for equipment, even though we're giving equipment expensing treatment. And so there really is a big incentive for more structures investment in this tax plan because of that. And so then the question is, where do they locate the structures? And zoning is a big part of it. It's something that other CEAs have written about. But to the extent that the dynamic that we expect to see, which is that firms want to locate activity in places where there are a lot of available workers, then I think the zoning constraint will be a smaller one. But it's certainly a big deal in places like San Francisco and Denver.
Okay. Last question. What is the federal government going to make sure that we remain internationally competitive? And I'm going to add a little bit to that, because obviously the administration, they left the Trans-Pacific Partnership discussions. The administration has been very critical of things like NAFTA, the Korea Agreement, the World Trade Organization, held out the possibility that we will leave some of these organizations. There's a concern, especially in the business community, that will hurt us competitively by reducing our access to other markets. What's your response to that set of concerns?
Sure.
How does this administration plan to raise our competitive position vis-a-vis our trading partners?
Well, sure. And just a reminder of what an honor it is to have the role of chairman of the CEA. And one of the roles that the chairman of the CEA has is to be the chair of the Economic Policy Committee for the OECD and to chair those meetings twice a year. And I was just with DJ, someone I stole from Brookings to the CEA, when DJ and I were just at the EPC meeting in Paris. And we could both tell you that many of our friends at the OECD meeting had the same question. And I think that for competitiveness, the tax component is certainly part of it. But there's also, I think, a sense that every president that economists I know has served over the years, that there's a lot of asymmetry in our trade deals, and that trade deals could be made a lot better. And I have not talked to people in the White House. I've not heard someone say free trade is bad. I've heard people say that our deals are asymmetric, that they disadvantage the U.S. And really, if you look at the details of those deals, who could argue with that? I can remember once I was on television with Austin Goolsbee, and Austin said, an economist's free trade deal is one line, says we got free trade. But the free trade deals that we look at have thousands and thousands of pages. And he was explaining President Obama's policy on free trade. And I think that if you look at the negotiations that are going on, I'm very hopeful that they'll reach a positive outcome that's better for America and improves our competitiveness, because there are so many asymmetries in the deals.
Kevin, thanks very much for coming and talking about all these issues.
Thanks for having me.
All right.
Thank you.
Okay.
Thank you. We should go.
We're now going to start with our second part of the event, or our first panel here, which is on best practices for strengthening R&D pipelines. So as Bob mentioned at the start, we're thinking of this event as broadly about innovation and things that can drive innovation and living standards, but we're going to try to drill down on a couple specific areas here. And we have a terrific panel here. We have, starting from farthest over, we have Josh Graf-Zivin, who is a co-author on a new Hamilton project policy proposal that he's going to talk about at the start of the panel. It's one of the 3 little booklets that were handed out to you as you came in. It's a policy proposal on promoting energy innovation with lessons from drug development. And Josh is a professor and associate dean of faculty affairs at University of California at San Diego. We've also got Ryan Umstattd, who is the acting deputy director for commercialization at the Advanced Research Projects Agency Energy, or ARPA-E, as it's more commonly known. And we also have Richard Moscicki, who is the chief medical officer and executive vice president for science and regulatory at PhRMA, the Pharmaceutical Industry Association. So just to set the stage very briefly, as Bob mentioned at the start, I think we're well aware that innovation is a huge part of the growth in living standards over time. So if you look across countries, it is not just the capital stock or even the human capital stock or labor that really separates living standards, but differences in what we, as economists, often call total factor productivity, or the efficiency with which we combine all those inputs. That becomes a huge difference to our living standards across countries, and also for any given country over time. And in particular for countries at what we think of as the frontier. For them, it's innovation and technology growth, total factor productivity growth, that is a huge portion of what drives living standards over longer stretches of time. And so we'll try to think here a little bit about, on the one hand, why it's so important, but also what are some of the barriers that we face when we think about innovation. And in the document that Bob mentioned, the third piece we've handed out to you, besides the 2 policy proposals, it's a document about 11 facts on innovation and patents. And beyond trying to think through some of the core features about innovation and patents, it also thinks about some of the barriers we face to them, whether it's declining federal R&D spending, whether it's the long lag from patent to profit, things like this that may make it harder to get the economy to generate this innovation. And so what we're trying to do here is think about a particular industry, to think about energy innovation. And so there are really 2 reasons to do that. One is just to take a specific example. One, problems in innovation vary by sector, and we can take one to try to learn some lessons, and in this case, especially learn lessons from one sector over to another. But also because energy innovation has some special characteristics about it. It's not just that it's a key input in the economy, but something that we probably won't touch as much on here, but it's an important underlying factor, is the fact that there are generally unpriced externalities in energy production. And so we've got, between pollution and carbon, there are reasons that we really worry about how efficiently we make our energy. And so that becomes an additional reason to try to make sure that we're getting all the energy innovation that we can, to make sure that clean energy is being developed and the inputs into energy are being done as efficiently as possible. And so with that stage setting, I'd like to toss it over to Josh to kind of walk us through his proposal, and then we'll come back to the panel.
Okay. I'm not sure which mic I'm using, so I'll stand in front of this one and keep this one on my lapel. Thanks, Jay. I just want to first acknowledge that this is the report that you all have in your folder is joint work, and at least one of my co-authors, Anna Goldstein, is sitting here in the front row, so she's here for moral support, so thanks, Anna. I have 5 minutes to cover a lot of ground, and so I'm going to gloss over a lot of things and try to maybe make 3 big picture points that we can elaborate on in our panel discussion as it progresses. And the idea here is to capitalize on what we know from biomedical innovation, the successes of biomedical innovation, in particular pharmaceutical innovation, and think about what we might take from that experience and port over, or what lessons we might draw for the energy sector. And I'm going to classify, and there are lots of commonalities between energy and biomedical. There are also lots of differences. I'm going to emphasize the commonalities here to talk about 3 distinct avenues that I think are worth thinking through. And they're going to fall into kind of 3 broad categories. One is in essence, the production of knowledge. The second is the investment in that production of knowledge, and the third is the incentives to create that knowledge. So on the production side, one of the things that has been breathtaking, at least to me as a scholar of biomedical innovation, over the course of what I like to think of as my relatively young, short career so far, what we've witnessed in the past 10, arguably 20 years, is explosive growth in something called contract research organizations in biomedicine. That is the idea that when you're developing a new biomedical product, you need to put that product through its paces, through its testing, and that testing is, frankly, quite expensive. And for very large pharmaceutical companies, there are resources to do some of that testing, if not all of that testing, in-house. But that for the smaller organizations, that was always going to be an obstacle. How are we going to actually provide the infrastructure, the simple infrastructure to run those tests? And so what I want you to have in mind here is that when we think about energy innovation, we're not thinking about app development. We're not thinking about software engineering in which the beta testing, the development, and all of that can happen in a dorm room or a garage or maybe in an office park. In energy, like in biomedicine, we're talking about very large infrastructure that's required to do this testing. And so one of the things that's noteworthy here in the energy sector that has shown has provided great help in the biomedical innovation is the absence of these institutions that can provide, as it were, shovel-ready infrastructure to help develop, test, refine products that require large infrastructure. And so one of the ideas that we put forth in our proposal, and I won't elaborate here, is that there may be a role for the national laboratories and to a lesser degree for universities to provide some of that shared infrastructure so that infrastructure is available so that it's not only the largest companies that have the wherewithal to do that necessary testing, but also provides lots of opportunity for those smaller entrepreneurs to get in the mix. On the investment side, one of the clear lessons we've learned from pharmaceuticals is that we have a very clear, if not always perfect, regulatory process in which drugs go through a very standardized evaluation process. They go through a stage gating, if you will, in which the promise of a particular product is evaluated at various stages. We have no parallel process, at least in any broad sense, in the energy sector. And so I've got my 2-minute warning. I'm not going to elaborate too much more on that, but I would argue that stage gating is particularly important as we think about private investment. That evaluation of products, systematic evaluation of products, is what allows external bodies to decide whether a product is promising and how and when to invest in it. And that infrastructure is I would say, patchy in the energy sector. Lastly, I want to argue in particular for direct financial incentives, and I'm picking on a particular piece of the energy sector here. There's lots of players in energy, but I'm thinking in particular about electricity and electricity generation and distribution. And one of the things that's absolutely true when you think about electricity in particular is that it is delivered by, for the most part, regulated highly regulated utilities, electric utilities, which have, at best, stultifying incentives to do any innovation whatsoever. And that's partly about the way in which we remunerate them, partly a legacy of the ways in which we've decided that energy should be publicly provided, and partly a result of I think, not sufficient creative thinking on how to get utilities from moving them away from simply delivering services to being part of the ecosystem of folks that are experimenting in this very real living laboratory where the infrastructure is already there to provide a backbone for that experimentation, to get them and incentivize them to do so. It is interesting to note that several states are moving in this direction. New York is really the leader. Of course, I'm from California, so we have to tout California as well. But there is much more work to be done, both at the state level and at the federal level, and I think that's a promising place to move. Let me offer one concluding remark that I'm a little embarrassed to say. I didn't quite recognize despite working in this area for many, many years and writing this paper over many, many months, I didn't quite realize till 2 days ago. And I think one of the things that's important and interesting to recognize here is that it's not an apples-to-apples comparison when we think about pharmaceutical innovation versus the energy sector. Energy is broad and complex and embodied in so many products. If you wanted a fair comparison, you would compare energy innovation to health innovation. And I think we would then be saying many of the very same things, because health innovation, we don't regulate gym memberships, nutrition, and all kinds of things that matter for health in the same way that we regulate and incentivize pharmaceuticals. One of the lessons that I draw away from that observation is simply the thing that we tell all of our graduate students, which is take a big problem, carve it into something more bite-sized and manageable, and then iterate from that size up. And so one of the things that the pharmaceutical sector has done very well, or the infrastructure and ecosystem around innovation in pharmaceuticals, is to carve out a piece that could be governed by some unifying structure. And I think that's going to be the key to our success as we build out more and more innovation infrastructure in the energy sector. Thanks.
Great. Thanks, Josh. So, Ryan, I'd like to start with you. And first, before I do, let me just remind everyone, as Greg noted during the last conversation, you either have note cards or note cards will be coming around. If you've got questions, you can write your question on there, and they'll come up to me at some point during this conversation. So please fill those out as we go. So, Ryan, could you give us your perspective, kind of from where you sit at ARPA-E, a little bit on how the energy innovation pipeline functions right now and some of the issues that you see with it, and in particular, if you've got any thoughts on kind of some of the things in the proposal about kind of the technical standards or kind of stage gates or things like that, and how that becomes an important issue you face in your work.
Sure. Well, thank you, Jay. And again, thanks to you and the Hamilton Project for inviting me to be a part of the discussion today. I really appreciate that. And just to help provide a little bit of context for my remarks today, I wanted to give you the 30 seconds on what is ARPA-E. We're a federal funding agency. We provide resources both in dollars in terms of active management of projects and programs in energy technology. And the reason we do that is because basically we're chartered with maintaining our technology in terms of technological lead, as well as we want to help maintain our energy and economic security as well. We do that by identifying potentially high-risk energy technology areas where if we can help with an investment of dollars as well as expertise, we can help de-risk the technology aspect, then that might help lead to greater energy innovations. And again, with the goal of either improving our efficiency, reducing our emissions, or reducing our energy imports. So that's what we do as an agency, and I work at the agency leading our tech-to-market team, where we take these technologies and try to help prepare them to be market-facing once they're done with their ARPA-E support. With regards to, the energy R&D, that whole ecosystem, and how you start from early stage to late, one of the things I think it's important to point out is that there's very few energy organizations left, whether you're a corporate or strategic, that can actually take something all the way from an early stage R&D up through prototype, out through demonstration, up to manufacturing and scale up and put it on the market, right? There's very few organizations that can do that organically, so you're going to have transition partners and stakeholders to work with. And to do that, you're going to have clear demarcations where you can, before you can transfer to a partner, they're going to have to understand what's the level of risk that's involved for them. And so I do think that having stage gates is going to be critical. Whether it's something like the technology readiness levels that we've seen NASA apply, as well as DoD and some other organizations, those might be helpful for those demarcations of, okay, we've bought down a certain level of risk, but it certainly, in our interactions with the private investment community, they love to see opportunities where you can show that you've had a step change in the valuation of your technology or your company. So that's going to be absolutely critical. And when you work in a hardware-based technology like energy, it turns out that the early stage R&D isn't usually the most expensive part of the step. So you have to have that those demarcations well justified of here's the technology risk that we've bought down with this particular project, so that you can encourage those other funding mechanisms to open up their coffers and say, okay, we understand where you are now, and we're willing to take on some risk ourselves. So I do think that that'll be extremely helpful. I'll close with a comment on something else that I've seen very successful in terms of not just giving projects momentum, but helping carry that momentum forward. And that is a concept of cost sharing or co-funding. So when you can, and it gets a little messy, but when you can mix together public and private sources of funding on a project, it creates a more gradual handoff or a transition instead of throwing something over the fence and hoping that the next transition partner catches it. So we've seen that be very beneficial. Both the public and the private partners benefit from each other. For example, the government process for due diligence when it comes to technology, and we evaluate proposals before we choose which ones to fund. I think that industry benefits a lot when we've already done some due diligence for them on that front. And we in the government side benefit greatly from the entrepreneurial expertise that our industry and private funding partners can bring to it. So again, those are all aspects that I've come to appreciate working at ARPA-E with the teams that we're helping support.
Great, thanks. So, Richard, we're in some sense holding up PhRMA here as saying, like, PhRMA has figured this out to some extent, right? Like and at the very least, if you look at the literature, typically you see, R&D spending as a share of revenue or things like that for pharma is really quite large, and then you look in the energy industry and it's nowhere near as large. And so I think in some sense that's the idea is there's something here that is enabling pharma firms to spend a lot on R&D and generate a pipeline with a lot of innovation. Where do you see that coming from?
Well, let me make a few broad strokes around pharmaceutical R&D to start with, and I'm delighted that we're holding it up as as an example of real success. And in fact, it has been a success if you even just look at the impact recently. I mean, we're talking about a situation where cancer deaths have decreased by 25%. Hepatitis C is now curable, and all of the subsequent complications of hepatitis C are dramatically going to be decreased. We have 500 treatments for rare diseases. I mean, that's unheard of, if we thought about it 20 years ago. And even death from heart disease has declined by about 35% since the year 2000. And this has been driven by pharmaceutical R&D and innovation in that space. But the future is still full of need, right? So we need this robust R&D pipeline. For example, Alzheimer's is looming over our society in a way that will be devastating if we can't find better answers. So to illustrate the robust nature of the pharma R&D pipeline, you can look at the fact that there are 7,000 active INDs today handled by FDA or filed with the FDA. And what supports all of this is a complex and large ecosystem that Josh referred to. And it has grown up organically around this, but it is highly interdependent. I've seen attempts to describe it in slides or graphs that sort of look like a complex electrical circuit going in many different directions with many different parts. And all of it plays a very important role, I think, in the success of the R&D pipeline. Let me just name a few of the elements in that ecosystem. So it really begins at the proximal end with investment, the lifeblood of that ecosystem. And I'll come back to that later because I think that's an important driving force to this. It's an ecosystem that depends on both academia, government, and industry to play important roles. On the academic and NIH side, you have basic science breakthroughs. The war on cancer, the war on HIV had tremendous spin-out in terms of the technical aspects that became very important to the kind of cures that I just talked about before. You have the pharmaceutical companies, large ones, medium-sized ones, and you have the small biotech companies, each playing a very important role in that niche. Industry also doing its own discovery work, then moving on through medicinal chemistry, translational science, clinical research, and you have the CROs who play a big role in this now and are capable of providing all of those kind of services that Josh referred to. You have the academic investigators. You have the regulatory oversight and the role of Congress itself, too, playing an important role in how it provides more investment and oversight into this area. And the regulatory oversight I sort of think of in this ecosystem like the the engineer in the locomotive, trying to actually steer this in the best possible way for the best possible outcome, so that in fact it does create a certain degree of assuredness to the ultimate consumer, the patient, that the product is in fact what it purports ultimately to be. You still also have the sales and distribution piece, and I'll come back to that because revenue is key. That is why there is investment, and that is it has to do with that being a successful effort. I'm going to skip over a few of the rest of this, but there is also ultimately in this ecosystem the role of competition in order to also control pricing, and the role of generics and biosimilars, where in fact there is this life cycle where the innovation has only a certain period, but to ultimately control costs, we do have the competitive generic industry, which now constitutes 90% of the prescriptions in America. So all of this is expensive, though, this ecosystem, and we spend around $80 billion per year in this ecosystem, and industry probably even a greater share than that funded by government in this setting. And that's driven by a very high cost of development. Figures, we talk about figures, whether it's right or wrong, you can argue, but when we talk about a figure of $2.6 billion per successful product, and 10 to 15 years of development, I'll just note that that's half the patent life generally that is eaten up just in the development period for these products. So it's not really an efficient system, even though we think of it as highly successful. It has a very high rate of attrition. Only about 1 out of 10 products that enter clinical trials, in fact, will make it all the way to approval and to patients. And in fact, that creates an incredibly high cost of failure in this system. And then even on approval, not all products are profitable. In fact, I saw a figure where only about 2 out of 10 actually get a revenue that exceeds the cost of R&D for those. CROs are in the midst of this, and they actually, I was trying to get a figure of how important a role they play. And so if we look at 80 billion on one hand, I saw one figure that the CRO industry expects about 34 billion in revenue. So it gives you kind of a perspective of the role that they do play in all of this. There is a tool that I haven't mentioned that brings together all these different elements of government, academia, and industry, and that's the public-private partnership. And that might be another tool to consider at some point in time, and how to jumpstart, because we have found in the pharmaceutical R&D space that this is often a tool that can help us get past some really difficult points where any one single company alone or academic institution alone really can't quite jump over it. So what drives this engine of innovation? Well, partly, of course, it's the mission. The fact that many people involved in this ecosystem are looking to add benefit in the relief of human suffering and life and death situations. And that plays a strong role. But I really believe that the driving engine, ultimately, for this innovation is the creation of high-value medicines at the end of this. That pull-through incentive is what allows investors to put that kind of funding into driving this ultimately forward. Now, realizing that high value does require a market-driven environment, which today we're somewhat under attack. And it may be this high value that I would just offer could be a primary difference with the energy sector, where on one hand, and here you have high value, at least for a period of time, whereas there you're thrown into a commodity situation where no matter how you innovate, the reward systems may not be there for the right ability to drive that forward.
And just before I move on, just because we've got a wide-ranging audience. Do you want to explain what a CRO is, just for anyone who doesn't know what
Contract Research Organization.
Okay, yeah.
So I think Josh, I think everybody heard Josh talk about
Yeah, okay.
CRO.
Just wanted to make sure. All right, so Josh, I wonder if I could come back to you with one issue, which is, so we're in Washington, and in Washington there's often a tendency to say, well, you know who could do that is the federal government could do that, right? Like, and then on the other hand, as economists, we're often put in the position of saying, like, why wouldn't the market just do that for you, right? And so I was wondering if you could think of some of the things you're suggesting here. So whether it's the creating standards or having some role in the standards, or for that matter, using the labs to be these contract research organizations, right? Whereas in pharma, they're not, right? They've got a $34 billion revenue stream that they're happy to take. So why government, right? Or why pieces of government? And why not just say, look, if this was actually worthwhile, the market would already be doing it?
So that's a great question. Let me say, I won't narrow my question just to those 2 points on why government.
Yeah.
But first, on the standard setting, I actually don't think it has to be government. It has to be a credible third party. And it's often the case that, so it has to be a credible third party that can certify where we're at in the process, and that can be held to a standard in which investors will trust that standard and invest on it. And it may be that the government is in the best position to be that standard setter, but it doesn't have to be the government. So I don't think that is necessarily a role for government. On the CRO side, I mean, one thing to keep in mind here is what I glossed over is, yes, they require big infrastructures, but the infrastructures they require are very different. What these clinical research organizations or contract research organizations are doing is they're providing human patients for clinical trials and in some cases some specialized equipment and statistical support. On the energy side, the infrastructure part of this is not human, it's physical, and it's at a scale that doesn't look like the biomedical side. And so it doesn't have to be the labs, but it's sort of hard to imagine who is in a position to provide that physical infrastructure. Well, what the role, I think, if we think narrowly about what we're asking the government to do in this case, we're not asking the government to build the labs. The labs exist. What we're asking the government to do is to think creatively about how to loosen the restrictions on the kinds of activities that can happen inside the labs. And this may even be a fundraising opportunity for the laboratories, because there may be organizations on the outside willing to pay for those services. The issue is just the physical capital costs are very, very large. The last thing I want to say, and I don't want to belabor it because I think it's a little off point, but I think it's important vis-a-vis the commodities point, which is it depends on what we're asking the energy sector to provide. Are we asking the energy sector to provide the same old vanilla energy but just at lower cost? Or are we asking the energy sector to provide energy with lower externalities, emissions profiles, and greenhouse gas emissions? If we're asking the energy sector to provide some of the latter, then we need to decommodify the electricity market, and that is a role for government. I don't know which government's going to step up and do it, but it's a role for government to step in and delineate the differences between quote unquote clean electrons and dirty electrons.
Ryan, I'm wondering if you could, so if we're thinking of some of the things that we can learn from pharma, also focus on some of the differences. So Josh mentioned some of these of, health is a lot bigger than pharma. Energy is this wide-ranging sector. And so I'm curious if there are other ways you think of this, of what we can and what we can't learn. And maybe the answer, part of it is just on this last point raised about commodity in energy versus pharma. But I'm wondering if you could pick up on that.
Sure. Well, yeah, I'd like to, I think I can build a little bit on some of those ideas. And that is that I'm not an electricity market expert by any way, shape, or form. I'm in early stage R&D for most of my life. But when you look at the market today and deregulation, it's quite complex. It's done differently in each region. But they are starting to value things more than just cents per kilowatt hour or dollars a gallon. It's not just a commodities market, right? To keep the grid running, you've got ancillary services. You need to have spinning reserve and operational reserve and frequency management. Right. As we start to value those things, then perhaps there can be an opportunity for a very innovative energy technology that does more than just put electrons on your outlet. And so it's about being able to put real value on things like the resilience of the grid. Those are, again, opportunities where we might be able to break away from just a plain commodities market.
Richard, this is a helpful tour of PhRMA there, and one of the other pieces of this proposal that Josh and his co-authors have is thinking about ways in which you may need the government involved on the incentive side sometimes, right? So we can do things with standards, we can do things with testing, but at the end of the day, in some cases, you also just need to get the incentives right. And so you talk about the high-value drugs pull-through being really important there. But then there's also the case in the pharmaceutical industry that there are some cases where you want something, but it's not going to have a high-value pull-through for one reason or another, whether it's on the vaccine side or whether it's an orphan drug or things like that. I'm wondering if you think there are lessons there that you could apply, especially in these cases where, unless you've priced the externalities, like you may want to set up incentives differently.
Well, I think that's a great point. So on the push-through side, there is de-risking the pathway. So, as I said, the attrition rate is high, the risks are high, particularly for true innovation. It's one thing if you're doing a me-too drug or a generic, the risk is low. But when you are truly innovating in this space, risk is great. And so you need that reward in front of you in order to take that level of risk. But in fact, if that reward is lower, then you should lower the risk. And I think this is where FDA, for example, has played an important role where it's provided expedited pathways as one way to try and lower risk. There have been things like the GAINS Act to help address our big issue of antimicrobial resistance, where, in fact, the market does struggle to provide the kind of incentive for this. And it again, sort of falls back on this idea of finding pathways, regulatory pathways that are of a lower risk level in order to justify your investments.
Great. So I just want to remind people that the note cards should be coming around. I think they're coming up to me fairly soon. So if you've got questions, make sure to have written those out, and I'll take a look at those any moment. I don't actually see anyone walking around right now, but I'm sure they have. So I'd like to broaden the conversation, and this is really, in some sense, for any of you, as we think about not just specifically pharma or not just specifically energy, but maybe within those contexts, because it's where your expertise is, what do you see as some of the biggest barriers to innovation that you worry about? When you look across the U.S. economy, and it's something that we as economists talk about a lot, we see productivity growth is down. That makes one say, is it that, as Greg said, I see innovation everywhere, but in the productivity numbers, is there something they're worried about, that we're not delivering this innovation into the economy? Is it we're not coming up with the ideas, we're not getting them into the economy? Where is it that you're worried you see barriers in either pharma or in energy that's getting us this innovation that's so important? I don't know if anyone.
I'll jump in because,
Sure.
Again, from the perspective of someone who's been engaged with lots of different R&D agencies through the many years, and that is that, the stovepipes of early stage and applied research and later prototype development and demonstration, those can be prisons and valleys of death. And so anything we can do to smooth those transitions, I talked a little earlier about, it takes a whole group of stakeholders to move something from early stage all the way out to market. But one of the things that we've found working in our early stage is that it's still important to, as an experiment within our agency, to get these researchers to do some work outside of the lab to complement the work inside the lab. And what I mean by that is that when you're done with the project that we're helping you work on, you need to understand there's lots of different ways to maintain momentum of that new technology. If you have success in the lab, you might be interested in, say, licensing that technology. You might have an entrepreneurial graduate student who says, I'm going to create a spin-off company and try to get private funds. You might have a well-established company or a strategic partner that actually wants to pull you in. Or perhaps there's still more research and development that needs to be done, and you need to look for a sponsor for that research and development. But you need to understand what those pathways are and start investigating them while you're doing the work in the lab. And we try to work with our teams to help them understand that they need to understand what's going to take to get from technology to market. They need to have thought through who's their transition partner, what are the potential transition partners, how should they be treating intellectual property as a prelude to the follow-on conversation here today is, you need to understand how are you going to capture value and protect it as in your intellectual property strategy, and you might even want some early thoughts on, okay, if this works in the lab, how am I going to manufacture it? How am I going to scale it up to the point where I can actually make significant units? If you've thought through those things, you're much more likely to attract the attention of those follow-on partners, those other stakeholders that might be willing to help carry you through the next phase after you're done with us.
On the pharma side, I think there's still the great element of serendipity in science. And now serendipity is often aided by funding. And so the more that there is sometimes funding in the basic science, I said it in my opening comments, but for example, I do believe the war on cancer provided the kind of breakthrough thinking that has led to many of the great advances in cancer in the last 10 years. And I think the same thing came out of the war on HIV in terms of antiviral technologies that could translate into things like the cure for Hep C. So I do think that still basic science plays a very important role in innovation. It's not the be-all and end-all, and I think the care and feeding of the ecosystem is important, and keeping the rewards open is important. And as I mentioned too, we can worry about the attack that's coming on that very short period and small part of the pharmaceutical market that bears innovation costs.
So just to follow on that point, I think all of us who work in the technology space and innovation space, I think we have a tendency to over-linearize the process. So we think, oh, there's the basic part, and there's this part, and there's that part, and it's compartmentalized, and it follows a very logical trajectory. There is a lot of meandering in this process. Just to fix ideas, just think about, so we have some work on the NIH funding process. 50% of all products that can be tied to NIH funding directly or indirectly are in disease areas outside the initial disease area under investigation. And that's already in a pretty narrow space. That tells you something about the lack of predictability of trajectory there. I think what it means to me as an economist is that there's just always and necessarily going to be a part of the innovation process where the rents are not appropriable by private actors. They're simply not. And we can call that basic science, or we can call it something else. There's a role to be played by someone who's willing to bear that risk. And I think the risk point is an important one, because basic science is risky. It's almost the most risky thing you can do because it's a fishing expedition. And so we need resilient institutions, governmental or otherwise, that can ex post can fail and ex post feel good about that failure, because that is a sign of appropriate risk. It can be a sign of appropriate risk taking, and I fear we live in a political, and I don't mean just in a Washington D.C. political, a socio-political environment in which failure is really not. While I live in California, where everyone talks about fail fast and often. Even in that culture, that seems to be more of a mantra than a way of living. We need to find a way to institutionally wrap our heads around appropriate risk-taking if we're going to push the innovation frontier forward.
Yeah, I think that, in fact, that led to the rise of the biotech industry in the pharma sector. To a large degree, for very large pharmaceutical companies, the enormous cost of taking a product forward into a very high-risk area, was daunting. And so there was an era of Me Too's that came out of that because that was less risky. But as everyone decided, in fact, that's not where real value is generated. Real value is in true innovation. The risk levels rose, but it was much easier for a small biotech company to fail than for Merck to fail. That really took those companies willingly accepted that kind of level of risk, and it almost was their raison d'etre.
So we've got some great questions here from the audience, so I'm going to try to kind of tick through a few of them. So one question here is, aside from quickening the process, how do we encourage investments in technologies that have a serious lag between the initial funding and commercialization? And so this is something that we've been talking about a little bit here that very much hits in both industries, where you've got this incredible lag sometimes. And so one option is, well, just try to get there faster. But what else can we do if we just accept, look, it's going to take a while to know we have something, whether it's because of safety or whatever else, where we feel confident that we can commercialize it. What are the key steps we need to be thinking about to make sure these innovations actually happen and don't die in the valley of, I've forgotten, it's the valley of death of ideas or something, I've forgotten what it, yeah.
Well, I think it's this balance in the pharma side of identifying failure early. When you know you're really going to fail, you don't keep plugging away at it and wasting your resources. But more importantly, it's really the staying power of the investment, right? That can see it through to a longer period of time. Often I think one of the big problems for the biotech industry is that it's funded through venture capital to a very large degree, where the horizon on an investment is often short and thought more in the period of 2 or 3 years, when you got a product that's going to take 10 years. So I think it's having the kind of staying power of sustained investment becomes really important.
Yeah, a couple of thoughts on that from my perspective, and that is, to increase the confidence of these investors and carry them along with you, there's lots of things you can do. One is, we talked on earlier, so I won't belabor that, and that is discrete points in time where you've de-risked and you have a step change in your valuation, right? That encourages investors, because one set of investors can get out and the next set can come in. One other option, again, energy technology, pharma, it's a long, hard slog to get from early stage to a product. So if you can perhaps have side markets or side applications that might generate an early revenue stream, then perhaps you can have investors that'll ride with you for a longer period of time. And as an example, let me give a way far out there example. Let's say we had a working concept for a fusion energy reactor core today. It's still going to take a long time before you can build a power plant around that and sell electrons on the grid. But maybe you can generate neutrons from that fusion source, and those neutrons can be used for medical applications, for materials testing. So there's a chance here that you might be working on an energy technology. It's going to take a long time, but if you can have early applications that are consistent with the overall direction you're headed, then you could have an early revenue stream, settle the investors a little bit better so that they're not so concerned about it taking longer to get there. And the last thing is just getting investors with a different mindset. We tend to think of venture capital as this homogenous pile of dollars and mind frame, and it's not. There are subsets of venture out there that are mission investors, that are philanthropic, and they're in there for out of values as well as values. And so if they can see it as a success, that they've created a change in the energy technology landscape, even before they've got a revenue stream, then maybe they're okay with that. And so it's also about finding that right set of investor values and principles consistent with the technology you're developing.
And I would just, I don't have much to add, but I would just say, I think we actually have financial markets that work pretty well for long-term investing. One of the things that's unique about the technology space is that we have this huge regulatory and policy uncertainty about when this thing is delivered 30 years from now, what's going to define the market for it. And so that is something we can very deliberatively act on now by at least signaling as a regulator and as a social policy community making entities what it is we want that to look like, and what it is, the environment in which it's going to be, what the demand side of that market is going to look like when and if the product is delivered.
So I've got a number of questions here, actually, that circle around some similar questions, primarily around the using the labs point. And so just to remind everyone, so if we're going to try to use the national labs as contract research organizations, some of the questions are, for example, so they pointing out that some of the labs have user facilities already, and so to what extent are we just saying we want to do more of that, or are there specific changes? And others asking, is it a question of changing the way they use the fees, because there are some nonprofits can use them in a non-fee capacity, and for-profits might in a different. So So how is it more specifically, and I know there's more in the proposal, but for the audience, how specifically are you thinking this could work? And then I'd be interested in Ryan and Richard, how they see the feasibility of using the labs in this way.
So I absolutely agree. There are interesting versions of this going on at a variety of the labs. I can't speak to all of them, but I can certainly speak to a few that I know reasonably well. I won't now in the interest of time. I think the issue really is maybe three parts. So when using the contract research organizations and provide physical infrastructure, it may provide intellectual capital. And then there's a question of remuneration in some form or another. And so insofar as it's providing human capital, that's basically government employees that are being taken away from presumably something else they would be doing. And so there needs to be some model for how they're compensated for that, and whether they're literally compensated for the hourly wage that they've provided or whether there's some model for co-invention and revenue sharing are open questions. I think, there are what I would call mini experiments going on at a variety of labs in a variety of capacities. I don't think we've coalesced around a vision for how these services should work at the labs. I think we do. I think we have a reasonable understanding of how it works when you want to use physical infrastructure. I think the model for how you use intellectual infrastructure is much cloudier, and I think that at least the folks that I've talked to in the lab, in the limited lab interactions I've had, there are lots of folks within the labs who have a lack of clarity in terms of what they can and cannot do in their job capacity. And so it may be that all of the infrastructure is there and all the possibilities are there, and all we need is clarity. I suspect that's not probably quite the case, but I think the short answer is we need to be more systematic about it. And I think in that process of being more systematic, we should certainly draw upon all the lessons we've learned from the individual experiences at the various labs who've been engaged in this to varying degrees.
Yeah, I think in the pharma space, contract research organizations are highly service-oriented. So that's probably not exactly the equivalent of what you have in the national labs. They are built for purpose. So they are there to do what the people coming to them want them to do, and they provide services now everywhere from very early toxicology to medicinal chemistry to formulation work. All of these kinds of early services are available, as well as clinical research support. And I think most pharmaceutical companies use them today for their phase 1 human normal volunteer trials because it's just too difficult for any one company to try and create the level of infrastructure for such normal volunteer studies. So, I guess developing the service-oriented component. And again, if the rewards are high, right, then, in our entrepreneurial world, you would think that people would begin to form these kinds of fit-for-purpose services for the energy industry that might really fill that niche in the way that that niche itches, I guess.
Yeah, and I'll add to that as well. And so while ARPA-E isn't involved in oversight or management of our national laboratory system, we do interface with them quite regularly. They are a valuable partner. They're an outstanding resource on a lot of the technologies that we fund. The vast majority of those teams include at least one representative from a national lab. A wellspring of excellent technology and ideas and expertise. They have, of course, played a role in supporting research that's been started elsewhere, right? We have cooperative research and development agreements that they can enter, that the industry can enter with the labs. But I would caution that as we look for, can the laboratories play a bigger and broader role in providing resources on a regular basis to industry, we would just have to do that with some sort of awareness of, if you're running a government-operated, government-owned but contractor-operated facility, the more money flows in from outside of government sources, the less influence there really is for the government over what actually is being done in these labs. So kind of harkening back to the manpower, right? The people are, they'll answer to who's paying their paycheck versus who's actually in their management structure. And so we just have to do that judiciously and understanding, where the government may be stepping back and away from trying to direct what's being done with the funds because there's so much funds flowing from external to the labs.
Interesting. One of the other questions that came up a couple times here is thinking more broadly about the federal role on the just actual straight up funding side, right? So we can talk about setting the rules of the road and all these other things, but then there's also just here's some cash to do R&D, or not here's it to you, but just doing it. And so how do we think about the decline in federal funding for R&D and how big a role it's had shaping these innovation pipelines?
I'll say that I'm not going to advocate for more or less R&D funding because what to me is really exciting about an organization working where I work now is our model, right? And so I feel like even if other countries are going to start spending a greater share of their R&D in energy development and things like that, what if the U.S. can actually change the model for how we oversee and manage those R&D dollars? What if there's something special about making the laboratory people that are typically PhD scientists think a little bit outside of their lab and have to worry about, wait, who would actually buy this if this succeeds? And so I'm excited by the opportunity to work on that model and see if we can actually generate better results that get to market faster because of the model of the funding agency, regardless of how many dollars are actually coming our way.
I would just say on the NIH biomedical side, which is the side that I've done the most research on, our work suggests that the returns on investment from the NIH are net positive purely in commercializable product if you trace them properly. One thing that's interesting that comes out of that work, not just our work, others have shown this as well, is that as budgets contract, the things that get left off in terms of financing are the riskiest projects. And that's very logical from an institutional perspective, but if what you think you're trying to buy with basic government-financed R&D dollars is risky basic science, then the fact that you're moving, as you slash budgets, you move to inherently more conservative research investments, that troubles me because it suggests that the things we're dropping off on the margin are the things that are most valuable to invest in as a public institution.
From the pharma side, I guess I'd come back to still encouraging government funding of basic research, such as at the NIH. But I might take it a step further, funding translational research, too. For a long time, that sort of fell out of academic favor. But I think now, specifically targeting, bringing back, and offering rewards for the development of translational research is really a key bridge that needs to be developed to get from basic science to get to real products for patients. And so that's, I think, an important area for increased funding from the government. I think the other side is to, if the market situation doesn't itself provide adequate pull-through, is the idea of creating other kind of incentive rewards or awards. So I don't think it would work in energy, but I don't know it well enough to say, but such as exclusivity, whether it's data exclusivity or whether it's market exclusivity, has played a very important role. I think it's probably the biggest reason we have really 500 orphan drugs today is with the Orphan Drug Act. And the kind of 7-year exclusivity that provided. But there are other ways. I mean, if you really want new antimicrobials, but you're not willing to necessarily do something to create a market for those, and maybe you shouldn't, but what if you had a $500 million reward for a new antimicrobial that you could put on the shelf and have in case you really needed it someday for that flesh-eating bacteria that sweeping through the country.
Well, on that last note of flesh-eating bacteria, I've been flashed the time is up sign, and if I don't pay attention to it, it probably seems rare that anyone would. So I guess I'll pay attention to it. And with that, just thank Josh and his co-authors for a really interesting proposal, and thank Ryan and Richard for their comments here as well. And we'll have a short break, and then we'll resume with a panel on patenting. Thank you, everyone.
Thank you.
everybody. I'm Tim Lee. I'm a tech policy reporter at Ars Technica, where I cover patents, among other tech policy issues. And I'm delighted to moderate the panel on Melissa Wasserman's paper about decreasing the incentives for the Patent Office to grant invalid patents. The patent issues that I write a lot about are often about patent trolls and about the validity of software patents. And those issues, I think, kind of have a hot-button flavor where there's a lot of people getting angry about things on one side or the other. And I really like this paper because it has some more kind of pragmatic procedural changes where it seems like there's some clear misaligned incentives within the patent system and within the patent office that could potentially be better aligned and allow what I think everybody wants, at least in theory, which is a higher rate of granting valid patents and a lower rate of granting invalid patents. And so Melissa Wasserman is a law professor at the University of Texas, Austin, and she's done several papers with her co-author Michael Frakes. And this latest one is kind of a summary of her recent research in this area, and she has three, I think, really interesting proposals for giving the patent office and the people who work in the patent office both the time and the incentives to really look at patents thoroughly and reject patents that are not valid. So go ahead and take it away.
Yeah. What I'm presenting or summarizing today was co-authored with Michael Frakes, who is a law professor at Duke University. And so the United States Patent and Trademark Office's primary task is to review inventions to determine whether they merit the grant of a patent. And the agency seeks to provide both timely and high-quality review of patent applications. However, it's becoming increasingly difficult for the agency to accomplish this mission. The Patent Office, which processes over 500,000 applications each year, routinely faces budgetary shortfalls, high examiner turnover, and a crushing backlog of patent applications. So it's not too surprising, given this environment, that the agency at times will make a mistake and allow invalid patents to issue. And so these are patents that fail to meet the legal patentability standards. So invalid patents unnecessarily reduce consumer welfare. They can stunt productive research and discourage innovation. And despite the general agreement that the Patent Office is granting too many invalid patents, the policy discussion has, really until recently, not been informed by compelling empirical evidence regarding particular features at the agency that may, in fact, induce the agency towards granting patents. And so without sound guidance as to which features of the patent process may actually be leading to the granting of invalid patents, policymakers are less trying to fix the patent system without understanding the root cause of its dysfunction. So we hope this is about ready to change. Recent empirical work employs a range of empirical techniques to show a causal connection between certain features of the agency and its granting practices. And our proposal draws heavily upon these recent empirical analysis to recommend 3 changes designed to eliminate structural features of the patent system that bias the agency towards granting patents of questionable validity. So the first thing that we propose is that the Patent Office's fee schedule should be restructured to minimize the risk that the agency's revenues will be insufficient to cover its operational costs, and also to diminish the agency's financial incentives to grant patents when its revenues fall short. So the overwhelming majority of the Patent Office's costs are attributed to reviewing and examining patent applications. To help cover these expenses, the agency charges examination fees to applicants. However, these fees fail to cover half the costs incurred to the agency to review applications. So the agency is heavily dependent upon 2 additional fees that it only receives if it grants patents to make up for this deficiency. And that's issuance fees, which are paid at the time the patent is granted, and renewal fees that are paid periodically over the lifetime of an issued patent so that it will remain enforceable. So combined with examination fees, this makes up the vast majority, over 85%, of the agency's budget. So one immediate concern with this back-end fee structure is that it creates a risk, right, that the agency's fee income will not cover its operational expenses. So, for example, any unexpected dips in renewal fee income means the agency is going to be facing a budgetary shortfall. So an equally troubling problem, though, is that this back-end fee structure creates a strong incentive for the agency to grant patents. And this is particularly true when the agency is experiencing a budgetary shortfall, because in essence, it can generate revenue by granting additional patents and collecting that issuance fee and renewal fees in the future. Now, specifically, what we propose is that the agency increase its examination fees to equal its examination costs while abolishing issuance fees. So if examination fees are set to cover the costs, right, the financial risk facing the agency would be significantly reduced. And because the empirical evidence suggests the agency only acts on this incentive to grant additional patents to raise revenue when it's financially constrained, we think the bias towards granting patents to generate more revenue will also be extinguished. Our second proposal for the agency is to limit something called repeat applications. So unlike its foreign counterparts, the U.S. Patent and Trademark Office can never truly rid itself by rejecting an application. Rejected applicants can always restart the process by choosing to start or file something called a repeat application. And the consequences of this action can be overwhelming for the agency, which has stated that repeat filings have a crippling effect on their ability to examine applications. And over 40% of the agency's crushing backlog of applications constitute these repeat filings. So the Patent Office does collect fees when repeat applications are filed, but again, these fees are insufficient to cover the examination costs. So if the agency finds itself in a place where it's under financial strain, repeat applications just can compound these financial woes. So unfortunately, one effective strategy with combating this backlog of applications would be to grant more patents, right, even if they're invalid, because that's the only way that the agency can truly rid itself of the application for it to go away. So our third proposal is to increase the amount of time allocated to patent examiners. So patent examiners now, on average, spend about 19 hours reviewing a patent application. And because patent applications are presumed to meet the legal standards when they're filed, if an examiner does not spell out or set out the reasons why you need to reject the application, she must grant it. So if examiners are not given enough time, right, to do a prior art search, they may be in the position to allow patents they would have rejected if they had been given sufficient time to vet the application. And empirical analysis demonstrates that an individual examiner's grant rate rises dramatically when they experience promotions that bring with them a reduction in the time to review applications. So for example, as an examiner moves up the general schedule scale, so they go from a GS7 all the way up to a GS14, this progression is associated with about half of their examination time being cut in half. And what we see is their grant rates increase by as much as 13 to 29%. And so this pattern suggests that time allocations are binding on examiners and may be inducing them to allow patents of questionable validity. And because this appears to be more binding for experienced examiners, we propose that their time allocations be particularly increased. So I just want to close by saying the Patent Office has the legal authority to adopt many of our proposals, although some will require congressional action. And I also want to say we acknowledge that many of the features of the Patent Office that we address involve a broader range of considerations beyond the Patent Office's incentive to grant patents. So for instance, right, the agency's optimal fee schedule need to take into account both the agency's incentives as well as applicant incentives. And we attempt to sort of balance this complexity in our proposals as well.
Thank you. So related to that, to the kind of broader questions, one of the big concerns I think a lot of people are going to have with a proposal like this is that the Patent Office currently offers a graduated fee schedule with large companies paying significantly higher fees than small companies and individuals. And I know you have some details in your paper about how to deal with that, but I wanted to turn to Lisa Cook, who's a professor of economics and international relations at Michigan State. I know this is something, the kind of access to the Patent Office is something you've written about. I was looking through your research, and you look particularly at the kind of relationship between the Patent Office and African Americans going all the way back to the pre-Civil War era. So I'm interested in your thoughts about how a proposal like this might affect the access of African-American individuals and individuals more generally who don't have a lot of money, who aren't part of a big company, their ability to apply for patents and obtain patents?
So I think it's an interesting question. It's not something that I've looked at closely. So most of the work that is solely on African Americans has been historical. Most of the work that I do now is with respect to African Americans and women and the relationship between diverse teams and GDP. So I think that it is critical that we make sure that there is access at the beginning because, as we know, patenting is a small slice of inventive activity. And the way we can take advantage of the literature that suggests that diverse teams are more productive, and just to give you one example of this, is my co-author and I, Chaliampong Concharan, found that co-ed patent teams are more productive than single-sex teams, either single-sex male or single-sex female. So I think there's some room for greater efficiency at the beginning of the process to raise patent quality if you have more women participating, more underrepresented minorities participating. And there's several ways to possibly achieve that. With respect to access at the beginning, sort of figuring out, as the learning analytics literature is trying to do at the University of Michigan, at Michigan State, at the Big Ten universities, how women learn. So, and this is, it may sound derogatory, but actually it is a thing. And we find that different learning styles are more conducive to women learning STEM. There is one paper that shows that GDP per capita can be lifted by 2.7% if more women got more BAs and STEM degrees. What we show is that if more women and more African Americans participated, GDP could be as high as 5% higher. So what we need to do is to figure out, given these fairly significant increases we could have, is figure out how to do this either with respect to policy or with respect to firms. Firms are the most prevalent place that engineers, inventors show up. So there are policies and practices that could be put in place to make sure that they don't leave, because this is something that is a common feature for women and for African Americans, is that they leave STEM fields. They leave STEM occupations. And if we want to get greater diversity, if firms want to make money, if diverse teams are more productive, then we need to figure out how that can happen. And firms need to just say, or stakeholders in firms need to say, we're profit maximizing, therefore we should maximize diversity of these teams. With respect to the federal government, there are other things that could be done, like enforcement of workplace environment policies and practices. But that's something that firms can do, that educational institutions can do as well. But I think it all starts at the very beginning, education and training, to provide access to people who would like to be inventors, who would like to be a part of the inventive process.
All right, thank you. Melissa Wasserman, can you, let me ask you to go a little deeper in terms of this question of access to the patent office for people who don't have a lot of money.
Right.
I believe the current system, the small business pay half the normal fee, and then if you're a micro organization, a quarter of the regular fee, which is designed. Would the proposals in this paper, would that preserve that kind of structure, fee structure?
Yeah, so let me just say a couple things. So one, I think, thing to keep in mind is that the U.S. Patent Office has higher fees than many of its foreign counterparts, including Europe and Japan, for example, if you're trying to get 20 patent claims through. And so one concern you could say with our proposals is we are suggesting for small entities, right, that fee be brought up to costs. And so one concern would be, is that going to decrease the access they have? So there have been some studies that have looked at, if you raise costs, what kind of association do you have with the decrease in filings? And it's found it to be relatively inelastic, and part of that may be related to the fact that most of the costs associated with getting a patent application is related to attorney fees, not the fees associated filing. And if we did see some decrease in filing, that might be good to the extent that these are the lower quality ones that they're sort of pre-screening out to file. But our proposal does suggest that these small entities could get sort of a rebate back. It would just come from the renewal fees that would be paid to the Patent and Trademark Office. And what we really do is sort of shift the risk that if there's not enough fees to cover the cost, instead of that falling on the PTO, which is how it does now, the rebate that small entities may get would be not 50%, it might be 40% that year, right? But even then, if that's still concerning, we think, to sort of small businesses, given how innovative they are, we think just increasing the examination fees for large entities would go a long way. 80% of the applications filed at the PTO are large entities, and so that would help really bring financial stability to the agency and also substantially decrease any financial incentives they may have to grant patents when they're facing a budgetary shortfall.
So let me ask Ed Black, who is the CEO of the CCIA, which is an industry group that represents computer and communications companies, to kind of go to the real world perspective here. So obviously there's this potentially misaligned incentives. There may be too many patents being granted. Do you see the kind of effect of that on the companies you represent or the industry more broadly? And what does that look like?
Well, certainly it's a massive impact. I mean, step back for a second. The patent system is designed to really promote progress, science, useful arts, in essence, to help society by letting information flow, good ideas being created and disseminated. And the system is designed to facilitate both the intake of ideas and the dissemination. And so we look at the patent system as how well is it performing that basic function. And when you have high quality patents, the litigation rules, the examination rules, everything work pretty well. And it winds up, we think, being an asset to the process of innovation. But once you start introducing substantial numbers of bad patents, of weak patents, whatever, however we want to describe them, the system malfunctions. It screws up the dynamics at every stage of the process. So we're very, very concerned about trying to, at the front end, try to prevent bad patents. And if the system then nevertheless produces them, to have a system at the end, which is another double check, a second look. The dollars involved are massive. I don't think anybody will not have maybe heard about some of the lawsuits between some of the bigger companies. We're talking, frankly, just in terms of what's on the table in terms of lawsuits, it's maybe $30 billion. But you add in legal fees, you add in the cost of the companies in a variety of ways. About 20 years ago, one of my eye-opening, I went to Silicon Valley and I visited some companies about a whole range of issues. And a company, which I think I remember was Intel, one of their deputy general counsels took me up to take a look at his operation, and he introduced me to people around the room. And lawyer, engineer. And the engineers were people who were taken off of important research projects to support the legal team in dealing with both applying patents and scoping out what was the patent liability issue that they would face. And it was, even way back then, it was a tremendous cost. Now, a big company, it can be a big cost. They have a huge amount of risk. But for smaller companies, that can be crushing. There's a huge cloud that hangs over a lot of startup potential and venture capital people that if they think a company is going into an area and that we know there are a lot of patents out that could infringe, that you could be infringing on if you enter this area of manufacture. It's like we don't want the risk. It's just not worth the hassle. We've seen too many examples of companies that were, in fact, fairly innovative and dynamic. Some legacy status players were threatened by it, and they sometimes went out of business, sometimes they shriveled up, but they definitely lost the edge that they had. One that may hit the press back a number of years ago was Vonage. Vonage basically was VoIP, early leader in it. Legacy phone companies, basically, they all joined up and went after Vonage on patent basis, regardless of exactly validity. I think those cases were maybe not well brought, but even regardless, it was a good example of what happens when deep-pocketed players, okay, or just people with good lawyers, want to target somebody who does have either a deep pocket themselves or has a competitive product which could jeopardize and destabilize a status quo marketplace. So the impact on the companies financially is immediate, and the risk of liability, the impact on terms of their R&D internally, their strategic decision of what markets and new products to develop. Those are all costs that are very substantial. I think many companies woke up to the fact when they started seeing verdicts that were $1 billion or lawsuits for a couple $1 billion that it could, what that could do to them. They realized that there was a risk level. The one other element I would simply point out is that a lot of the suits were in technology companies, but when you really have a broad patent, a patent which doesn't have good boundaries, you could use it against a mom-and-pop barbershop who uses an internet process that somebody claims a patent for to notify customers. And the retail industry got into this a number of years ago because they were being hit, and restaurant industry, they were getting hit by patent lawsuits for doing common sense, everyday things, which had somehow managed to get a patent and were basically being extorted. Now that's became known as a patent troll problem for both for tech industry as well as the non-tech. But we also have the bullying, and I kind of related to the bullying patent, where they may not be companies that are, there are companies who basically don't make anything and they just license products. And then you've got ones who, frankly, the really bad category that I think is go after the restaurants with defenseless people who have nothing to fight back with and resources. And so while I focus mainly on the tech impact on tech industry and its harmfulness to innovation, the truth is it is a significant problem overall. And if you can deal with patent quality, you have dealt with not all of the problem, but a lot of it. And front end and back end are both important.
All right, thank you. So we have a question from the audience about the evidence for this theory that the USPTO becomes more generous if they have revenue problems. And I believe that the Hamilton Project did ask the Patent Office to send a representative, and they were not able to do so. But I assume if we talk to them, they would not say that, yes, we are deliberately lowering patent quality to increase revenues. Right. So I'm wondering if you could talk a little bit about what's the kind of evidence that is in fact happening, and if they're not doing that deliberately, what kind of process, what's your kind of model for how a revenue shortfall leads in a practical way to lower patenting standards?
So that was based on, what we looked at was an empirical study that looked at changes in sort of the agency's financial need, right? So we know how many applications are being filed, right? We know what their budgetary stream is, and we would know how much money they would need in order to process all the applications that are coming in. And so we were able to sort of construct an index of the agency's financial health over time. And then what we looked at was the agency we hypothesized, right, that when they're financially constrained, they'll have an incentive to grant additional patents in order to generate more revenue, but it's not uniform across all patents. So, for example, you're charged the same amount of renewal fees regardless what technology you're in, but some technologies renew at a much higher rate than others. And so we thought that the agency would likely target, that those sort of groups of technologies that have a higher renewal rate because they're more likely to get additional funds. And we also thought that there's a difference, we just said, between large and small entities, right? And so when they're financially constrained, will they target those technologies that are dominated by large entities, right? Because they're also likely to get more revenue for that additional patent grant. And so we use this as a sort of quasi-natural experiment, right, where we use sort of this treatment and control group, and what we saw was during these times of financial strain, they were differentially granting higher for these treatment relative to the control. Now, a big question we have there, is what's the mechanism, right? If the agency, for us talking to the agency, they definitely know, for example, they have to be at a certain grant rate to be in the black. right? They just know that on average, typically they need to be at this certain grant rate or they're not going to be taking enough money in. Now, what we would need, for our theory is a much more differentiated or more targeted sort of granting practice. And you could imagine at least two different mechanisms. One would be sort of a top-down, right, where the director is actually, applying sort of incentive to grant more in certain areas than others. A second could be more driven by examiners. And we thought we might see it more with senior examiners who've been along for a while and may sort of more internalize what a budgetary shortfall would mean for them. Time, overtime would be cut. They wouldn't be hiring as much, something along those lines. And we did try to do a little bit and some other papers, right, to sort of get on, to see if we saw this sort of mechanism. We looked at art units that had more senior examiners in them to see if they had a stronger effect, and we saw some of that, which suggests that it might be an examiner-driven, although they're not mutually exclusive, right?
So here's a question that I think either Melissa Wasserman or Lisa Cook might have thoughts on. How might collecting demographic data on patent filers at the NPTO affect the granting process? What if that data were stored separately from applications so examiners couldn't discriminate? Did either of you have thoughts on that?
I've thought about it a little bit.
Yeah, go ahead, please.
So I think that it's a good idea and a bad idea. So it caused me a lot of heartache when I was trying to put these data together 10 years ago, when there wasn't Google patents, and I had to match, I had to figure out who the African Americans were in the data set, and it wasn't easy at all. And the good thing was they couldn't necessarily be discriminated against, and what I found was that, say, in the 1920s, when segregation was, when Jim Crow laws were taking off, African Americans hid behind these patents, so they were able to keep inventing because nobody knew their race, right? So this was a protective mechanism at some time. But I would say that we have some good techniques to try to identify people these days, so I'm not sure that we need to collect them. The probabilities are going to be small with respect to identifying people, so I'm not sure that we really need to do that these days. But other people might have other ideas. But we have the ability to identify people using other means. So I'm not sure it's so necessary for the USPTO to collect this data directly.
Do you know if there's data currently about kind of, is there evidence of differential grant rates based on race or gender?
No, not that I know of. I wasn't able to detect that in the data. The patent application times, patent grant times were roughly the same for the historical data series that I have. So I couldn't find that. But early in history, yes.
I see.
Yeah. I mean, but I think that stopped with them adhering to, and when I say early, like the 1820s, right? So I think that practice stopped. But they can look at your address, right? I mean, there are other ways to get at who people are by looking at an address, especially if it's an individual inventor who is not patenting with a firm, because then the address becomes ambiguous, whether it's that person's residential address, and you can use residential discrimination or residential segregation to figure out who's where. Right.
And for people who don't know the patent process super well, but in most cases the examiner never meets the applicant, right? It's a all paper kind of process.
Right.
Yeah. So I've got a couple questions about the small entity question and about whether if raising the fees would help lower the invalidity rate. Is one factor there that is there a differential? Do small organizations tend to apply for more invalid patents?
Well, I think that overall the grant rate for small entities is lower than the grant rate for large entities. And the thought process is not, I don't think anyone is to sort of suggest the agency is biased against small entities. It's more of probably an early screening effect, right? That for a patent to get from a large entity, you're going to have sort of patent counsel, right, sort of screening and doing a better ex-ante screening process. You know, the other issue also could be is that, you know, just small entities may not have access to as effective counsel, right, as well. And I know that the Patent Office has done, you know, has some programs to help small entities get patents, right? And this is something that they're very aware of. And there are some avenues that you can utilize that large entities don't have available to them.
In fact, the USPTO has had me at 2 of these forums in Dallas and in Pittsburgh, and they invite small entrepreneurs to these forums to help them apply and to get access and to figure out where there may be access issues. So they're gathering information and they're giving information.
Yeah, and I would also just say, like, kudos to the PTO with respect to data more recently, right? I mean, they've made a big efforts to put out a lot of patent data and a lot more information that's come out in the last 5 years that have allowed a lot of more, it's sort of like booming now, I feel like, this, this research in this particular area, and that's been fantastic to see.
So Ed Black, you were talking mostly about the kind of burden of invalid patents on innovators who are not the patent holder. Do you have any thoughts from talking to people in industry and inventors, how significant this fee increase would be as a practical matter? Would you think there are a lot of companies that would be dissuaded from filing valid patents as a result of the kind of reform that she's talking about?
Well, I don't know how much empirical research has been done, but there have been some folks who've gone out and done some interviews in the venture capital world. And I believe I saw a number that said very high, like 8 out of 10 venture capitalists pretty much said they had encountered situations where, in fact, they didn't want to invest because the risk was substantially high, that they would have problems, and that they backed away. But overall, it's difficult to know. When you're doing it in the venture capital world, you also have the question of how much legal counsel does either party have early in the process. In other words, if it's a small company, have they already looked at the issue, or the venture capital guys, do they have a legal team that early looks at that, or is that a later stage where they get more deeply involved as things evolve? I suppose the liability issue as a deterrent is one that I think is probably one of the more significant and dangerous things for a society that wants to be innovative. It's harder to evaluate a dollar impact in any short-term way. But it is the societal implications, I think, are great.
Well, what about the cost of obtaining patents? I assume many of the companies are also on that side of it. Is there a point at which fees would become too high and you'd have a lot of legitimate patents that aren't getting granted because companies are not willing to pay those fees on the front end, or and the levels we're talking about, is it still not significant?
Yeah, I'm not sure I think that's a huge high risk. The truth is, patents are generally, if a good patent system is good for society, I think we'll find a way to deal with it. I think what the study shows is, though, tying compensation or funding for the entity to the numbers is dangerous. So whether what you do in terms of fees, high and low, is significant. And one of the remedies is obviously proposed is to raise fees, but that is to break the tie with funding extra patents. There may be other ways to provide funding. I mean, I don't want to get into PTO funding over the years. It's been fights in different ways. But I think the risk of good patents, the big cost is not the fee. It is the lawyers. It is the background. It is getting ready to do the patent. Those are relatively static costs that are not going to be affected by this.
Yeah, and just to clarify too, so just to give you some numbers, it's about $1,600, right, for examination and search fees at the USPTO for a large entity. It's about $5,000, right, for Europe for the same number of claims. And even though we're suggesting, doubling the examination search fees, we are also suggesting eliminating the issuance fee, which is, I think, about $1,100 right now. So, what we're trying to do is sort of spread some of that cost more up front, right? But you could structure it in such a way that the overall fees sort of associated with applications would remain relatively the same. We're just shifting more of it up front to help decrease the financial incentives possibly to grant patents.
Right. I wonder if we could go a little deeper on the question of examiner time. I think
Yes.
this is the piece of the paper that I felt was the newest to me. Like, I'd heard the other two arguments and they kind of made sense, but this was something I hadn't really heard about. Talk to me about, like, kind of what it's like to be a patent examiner, and then what you see over the career cycle. It was interesting that they kind of get more stringent and then they get promotion and suddenly get less stringent. Like, talk about kind of the findings you found there.
Yeah. So, we said examiners on average get 19 hours. This is to read the application, right? To write their office action, which is outlining the reasons why it should be rejected, right? To respond to what the lawyer argues for why it should be accepted, right? To do their final office action, and sometimes it also involves like a telephone interview, right? So it's not a lot of time. What they spend. What happens, and it makes sense, right? As examiners get promoted up the GS scale, they probably get better at doing their job, and they can do it with less time, right? And that, I think, generally makes sense. Our concern, right, is that scale of which their time gets cut as they get promoted may be too aggressive. There may be some amount of time that an examiner needs to do a good prior art search, right? And that they're just scaling it too aggressively, so that when you get hired as a GS7, you have twice as much time as by the time you get to be a GS14. And our data sort of demonstrates or shows some evidence, right, that is in fact what may be occurring. And so one thing that we could think about with the time allocations, and so what happens, right, is if you pull a GS14 examiner, you're going to have a higher likelihood to get your patent granted because they have much higher grant rates than a GS7, a lower examiner. And so there's this inequities about this concern that whether your patent gets granted or not may involve on the happenstance of what random examiner gets assigned to your application, because it's generally, the application comes in, gets assigned to an art unit, and then it's randomly assigned to an examiner within them. And so you can imagine sort of rethinking the time allocations, right, to make that more equitable, right? So they could shift the time allocation so that your grant rate stays relatively stable as you get promoted. But I do also want to be clear that we're sympathetic with the PTO, that obviously there's a trade-off between throughput, the number of applications the office can process, right, and the time that they give each examiner to review, right? And I think, and it's natural, right? The backlog is a very easy to identify, easy to see number that they're constantly combating with, right? And patent quality is something much more amorphous and much more difficult to measure. So we think there's some reasons to believe that the agency may be emphasizing too much backlog throughput at the expense of quality. And so we're sort of pushing the agency to reconsider that. And it's our understanding the agency's been very receptive to that and in our sort of in talks about possibly changing some of their time allocations.
So let me ask you kind of think bigger here. So you've been pretty careful here to kind of stick to what the evidence shows. But and so it obviously makes no sense to have the kind of grant rate depend on the seniority of the examiner in the way here. But one possible interpretation of this would be actually like that the correct number of hours is not within that margin, that maybe if we had 2 or 3 or 5 or 10 times as many hours per examiner, obviously that would cost more, but maybe the kind of optimal patent policy would actually involve a lot more examination.
Right.
What's your thoughts on that? I mean, do you think this is evidence that actually we should be giving them a lot more time?
Well, so I think one thing that complicates the matters, obviously, is, right, it's not just the PTO. You also have the courts involved, right? And so at some point, if we think there's very few patents that have economic significance after so much time, right, we would want to limit how much we do up front, and we would just rely on the courts to take out invalid patents. And this is also somewhat complicated by something called PTAB, which is this new adjudicatory body at the Patent and Trademark Office that can also review grants and invalidate them. So we did a little work on this as well, where we looked at sort of just litigation costs associated with invalid patents, and that if we increased the time allocations and we calculated how many fewer invalid patents would be issued and hence litigated. And our results suggested that we have quite a bit of wiggle room to put some more money up front, right? That it's not super efficient to be relying on the courts to the extent we are right now because litigation costs are so expensive. But the hard part is, obviously, is we don't know what the magic number should be, right? We just think that what we could put more up front than we are right now.
Right. One other thing that comes to mind here is that the courts, I believe, have a presumption that once the patent is approved, that the examiner did his due diligence, and therefore the court should defer to that up to a certain point. Do you think this has any bearing on the presumption? Should that presumption be a little bit weaker if we have evidence that had the examiner spent more time, they actually would have found prior art that, or other issues?
I mean, it's interesting because there was a Supreme Court case on this about prior art that was brought before if the examiner hadn't reviewed it. Should there still be a presumption of validity? And the Supreme Court said yes, right? So that's kind of passed, or we'd have to have some sort of, legislative override on that. We've had this sort of presumption of validity for a very long time. PTAB, for example, which is this adjudicatory body at the agency, doesn't have that. And patents are being invalidated, arguably at a higher rate there for a multitude of reasons. I think, it would make sense to possibly eliminate that for prior art that the examiner didn't consider, but I feel like I lost that, right? The Supreme Court has already spoken.
Well, in terms of costs, I think made reference to it again. The impact on industry of bad patents is a massive number. The cost of operating the PTO in an efficient way with extra resources is so de minimis compared to that number. And that's kept in mind. And I'm not sure I should say this, but one really bad patent can cause more damage than 100 good ones can cause benefit. So if the system is screwed up, I mean, it really can cause tremendous damage. And every little piece, every tool we can use to try to make it work better to produce high-quality patents only is well worth the effort.
I wonder if one other lesson here is that this presumption that the patent office needs to be self-funding, maybe that's wrong. If there's actually these large externalities, maybe, and obviously this is an environment where Congress is easy to throw money around, but theoretically, you can imagine just Congress saying we want twice as much money going to examination and we're just going to write a check because the gains from having fewer bad patents are so high.
Did you want to comment before?
Yeah, I just wanted to ask, so examiners are not penalized for having invalidated patents. This doesn't go in their record.
Right.
So that's an incentive that could change.
Yeah, that's an incentive that could change. There's actually very few applications of examiners that are pulled every year to do a quality check, right? Because it's so expensive to review them, right? Where production, how many they get processed is every single one of those is counted, right, towards their performance review. So there are ways you could imagine, right, to bring in this penalization. Now, to be fair to examiners, obviously sometimes it's invalidated not for their fault, right? The law changes, right? It's impossible. They're not given enough time. They may not be able to find the prior art that defendants could. Along those lines. I'm sorry, I forgot what you're...
I was just asking whether...
Oh, yes, whether they should be user fee funded.
Right.
So historically, the agency wasn't user fee funded. It was funded off of tax revenue, and then it changed to user fee funding. I would be very surprised if it changed back, right? As this is sort of not on the budget, right, when it comes in through user fees. But you raise a great point, because in many ways, the fee structure that might optimize patent applicant incentives is diverging from one that optimizes agency incentives, right? And to the extent we cannot manage both of those, we might want to do some decoupling, right, of having just pure user fee funded structure. And so one of the ways we try to get at that is we want to keep renewal fees because they perform this valuable function of effectively shortening the lifetime of a patent. If you don't pay them, it gets dumped into the public domain. But maybe the PTO doesn't automatically get to keep all of those, right? That gets earmarked into another fund where it's rebated back to small entity. But I think you hit, a great point about the user fee. I'm just not super optimistic in this political environment we change it.
Well, I remember the period when, in fact, a lot of people in the industry pushed to get out of a distant appropriation funding because it was so underfunded. They wanted more examiners. Their feeling was it was just unable to function well. But I'm not sure whether maybe there shouldn't have been a better recognition of the danger of linking it to, therefore, quantity and issuance. Right. And more than I think we have now, there has been over the years a philosophy that patent equals innovation, and that quantity is more important than quality. Right. Those two premises are tremendously damaging when put together.
Right. All right, I think that's all the time we have, so thank you all for coming.
Thank you.
Thank you.
Good job.